A water tower is an elevated structure supporting a water tank constructed at a height sufficient to pressurize a water supply system for the distribution of potable water, and to provide emergency storage for fire protection. In some places the term standpipe is used interchangeably to refer to a water tower, especially one with tall and narrow proportions. Water towers often operate in conjunction with underground or surface service reservoirs, which store treated water close to where it will be used. Other types of water towers may only store raw water for fire protection or industrial purposes, and may not necessarily be connected to a public water supply. Water towers are able to supply water even during power outages, because they rely on hydrostatic pressure produced by elevation of water to push the water into domestic and industrial water distribution systems. However, they cannot supply the water for a long time without power, because a pump is typically required to refill the tower. A water tower also serves as a reservoir to help with water needs during peak usage times. The water level in the tower typically falls during the peak usage hours of the day, and then a pump fills it back up during the night. This process also keeps the water from freezing in cold weather, since the tower is constantly being drained and refilled. Although the use of elevated water storage tanks has existed since ancient times in various forms, the modern use of water towers for pressurized public water systems developed during the mid-19th century as steam pumping became more common, and better pipes that could handle higher pressures were developed. In Great Britain, standpipes consisted of tall, exposed, N-shaped pipes, used for pressure relief and to provide a fixed elevation for steam-driven pumping engines, which tended to produce a pulsing flow, while the pressurized water distribution system required constant pressure. Standpipes also provided a convenient fixed location to measure flow rates. Designers typically enclosed the riser pipes in decorative masonry or wooden structures. By the late 19th century, standpipes grew to include storage tanks to meet the ever-increasing demands of growing cities. Many early water towers are now considered historically significant and have been included in various heritage listings around the world. Some are converted to apartments or exclusive penthouses. In certain areas, such as New York City in the United States, smaller water towers are constructed for individual buildings. In California and some other states, domestic water towers enclosed by siding were once built to supply individual homes. Windmills pumped water from hand-dug wells up into the tank. Design and construction. A variety of materials can be used to construct a typical water tower. Steel and reinforced price-stressed concrete are most often used. Incorporating an interior coating may be spherical, cylindrical, or an ellipsoid, with a minimum height of approximately 6 meters and a minimum of 4 meters in diameter. A standard water tower typically has a height of approximately 40 meters. Pressurization occurs through the hydrostatic pressure of the elevation of water. For every 10.20 centimeters of elevation, it produces 1 kilopascal of pressure. 30 meters of elevation produces roughly 300 kilopascals, which is enough pressure to operate and provide for most domestic water pressure and distribution system requirements. The height of the tower provides the pressure for the water supply system, and it may be supplemented with a pump. The volume of the reservoir and diameter of the piping provide and sustain flow rate. However, relying on a pump to provide pressure is expensive. To keep up with varying demand, the pump would have to be sized to meet peak demands. During periods of low demand, jockey pumps are used to meet these these lower water flow requirements, the water tower reduces the need for electrical consumption of cycling pumps and thus the need for an expensive pump control system, as this system would have to be sized sufficiently to give the same pressure at high flow rates. Very high volumes and flow rates are needed when fighting fires. With a water tower present, pumps can be sized for average demand, not peak demand. The water tower can provide water pressure during the day and pumps will refill the water tower when demands are lower. Using wireless sensor networks to monitor water levels inside the tower allows municipalities to automatically monitor and control pumps without installing and maintaining expensive data cables. Decoration. Water towers can be surrounded by ornate coverings including fancy brickwork, a large ivy-covered trellis, so they can be simply painted. Some city water towers have the name of the city painted in large letters on the roof as a navigational aid to aviators and motorists. Sometimes the decoration can be humorous. An example of this are water towers built side by side, labeled hot and cold. Cities in the United States possessing side-by-side water towers labeled hot and cold include Granger, Iowa; Canton, Kansas; Pratt, Kansas; and St. James, Missouri. When a third water tower was built next to the Oklahoma, set of hot and cold towers, the town briefly considered naming it Running, but eventually decided to use Home of Woody Guthrie. The house in the clouds in Thorpeness, located in the English county of Suffolk, was built to resemble a house in order to disguise the eyesore, whilst the lower floors were used for accommodation. When the town was connected to the mains water supply, the water tower was dismantled and converted to additional living space. Sapp Brothers truck stops use a water tower with a handle and spout, looking like a coffee pot, as the company logo. Many of the facilities have decorated actual water towers on site. The first and original Mushroomsvampen in Swedish was built in Örebro in Sweden in the early 1950s, and later copies were built around the world, including Saudi Arabia and Kuwait. Many small towns in the United States use the water towers to advertise local tourism, the local high school sports teams, or other locally notable facts. Since the water tower is sometimes the highest point in the town, antennae, public address systems, cameras and tornado warning sirens are sometimes placed on them as well. Many water towers serve manufacturing and other commercial facilities. These are often decorated with the name of the company that the water tower serves. Worldwide, the technology dates to at least the 19th century, and for a long time New York City required that all buildings higher than 6 stories be equipped with a rooftop water tower. 2 companies in New York build water towers, both of which are family businesses in operation since the 19th century. The original water tower builders were barrel makers who expanded the craft to meet a modern need as buildings in the city grew taller in height. Even today, no sealant is used to hold the water in. The wooden walls of the water tower are held together with steel cables or straps, but leak through the gaps when first filled. As the water saturates the wood, it swells. The gaps close and become impermeable. The rooftop water towers store 25,000 to 50,000 liters of water until it is needed in the building below. The upper portion of water is skimmed off the top for everyday use, while the water in the bottom of the tower is held in reserve to fight fire. When the water drops below a certain level, a pressure switch, level switch or float valve will activate a pump or open a public water line to refill the water tower. Architecture architects and builders have taken varied approaches to incorporating water towers into the design of the buildings. On many large commercial buildings, water towers are completely hidden behind an extension of the facade of the building. For cosmetic reasons, apartment buildings often enclose the tanks in rooftop structures, either simple unadorned rooftop boxes, or ornately decorated structures intended to enhance the visual appeal of the building. Many buildings, however, leave the water towers in plain view atop utilitarian framework structures. Water towers are common in India, where the electricity supply is erratic in most places. If the pumps fail, then water pressure will be lost, causing potential public health concerns. Many U.S. states require a boil water advisory to be issued if water pressure drops below 20 pounds per square inch. This advisory presumes that the lower pressure might allow pathogens to enter the system. Water towers are often regarded as monuments of civil engineering. Some are converted to serve modern purposes, as for example, the Wiesel in Wrocław, Poland, which is today a restaurant complex. Others have been converted to residential use. Historically, railroads that used steam locomotives required a means of replenishing the locomotive's tenders. Water towers were common along the railroad. The tenders were usually replenished by water cranes, which were fed by a water tower. Some water towers are also used as observation towers, and some restaurants, such as the Goldberg Turm in Sindelfingen, Germany, or the second of the three Kuwait towers, in the city-state of Kuwait. It is also common to use water towers as the location of transmission mechanisms in the UHF range with small power. For instance, for closed rural broadcasting service, amateur radio, or cellular telephone service. In hilly regions, local topography can be substituted for structures to elevate the tanks. These tanks are often nothing more than concrete cisterns terraced into the sides of local hills or mountains, but function identically to the traditional water tower. The tops of these tanks can be landscaped or used as park space, if desired. Spheres and spheroids. The Chicago Bridge and Iron Company have built many of the water spheres and spheroids found in the United States. The website World's Tallest Water Sphere describes the distinction between a water sphere and water spheroid thus: a water sphere is a type of water tower that has a large sphere at the top of its post. The sphere looks like a golf ball sitting on a tee or a round lollipop. A cross-section of a sphere in any direction is a perfect circle. A water spheroid looks like a water sphere, but the top is wider than it is tall. A spheroid looks like a round pillow that is somewhat flattened. A cross-section of a spheroid in two directions is an ellipse, but in only one direction is it a perfect circle. Both spheres and spheroids are special case ellipsoids. Spheres have symmetry in three directions, spheroids have symmetry in two directions. Scalene ellipsoids have three unequal length axes and three unequal cross-sections. The Union Water Sphere is a water tower topped with a sphere-shaped water tank in Union, New Jersey, and characterized as the world's tallest water sphere. A Star Ledger article suggested a water tower in Owen, North Carolina, completed in early 2012, 219.75 feet tall and holding 500,000 U.S. gallons, had become the world's tallest water sphere. However, photographs of the Owen Water Tower revealed the new tower to be a water spheroid. The water tower in Braman, Oklahoma, built by the Coronation and completed in 2010, is 220.6 feet tall and can hold 350,000 U.S. gallons, slightly taller than the Union Water Sphere. It is also a spheroid. Another tower in Oklahoma, built in 1986, 1946 and billed as the largest water tower in the country, is 218 feet tall, can hold 500,000 US gallons, and is located in Edmond. The Earthoid, a perfectly spherical tank located in Germantown, Maryland, is 100 feet tall and holds 2 million US gallons of water. The name is taken from it being painted to resemble a globe of the world. The golf ball-shaped tank of the water tower at Gonzales, California is supported by 3 tubular legs and reaches about 125 feet high. The water tower in Eindhoven, Netherlands, contains 3 spherical tanks, each 10 meters in diameter and capable of holding 500 cubic meters of water. On 343.45 meters spires were completed in 1970. Alternatives to water towers are simple pumps mounted on top of the water pipes to increase the water pressure. This new approach is more straightforward but also more subject to potential public health risks. If the pumps fail, then loss of water pressure may result in entry of contaminants into the water system. Most large water utilities do not use this approach, given the potential risks. Tallest notable Brazil Nave Espacial de Varginha in Varginha, Canada. Guaranteed pure milk bottle in Montreal, Quebec, Canada. Croatia Vukovar Water Tower in Vukovar. Netherlands Eindhoven Water Towers in Eindhoven. Polder Toren in Emmeloord. Water Tower Simpelveld in Simpelveld. Water Tower Hellevoetsluis in Hellevoetsluis. Slovenia Brežice Water Tower in Brežice, United Kingdom. Dock Tower in Grimsby. House in the Clouds in Thorpeness, Suffolk. Jumbo in Colchester, Essex. Tilehurst Water Tower in Reading. Tower Park in Poole, Dorset. United States. Brooks Catsup Bottle Water Tower near Collinsville, Illinois. Chicago Water Tower in Chicago, Illinois. Eiffel Tower at Disney's Hollywood Studios. Florence Yule Water Tower in Florence, Kentucky. Leaning Water Tower in Groom, Texas. Beachoid next to I-85 on the edge of Gaffney, South Carolina. Union Watersphere in Union Township, New Jersey. The Volunteer Park Water Tower in Capitol Hill, Seattle, Washington. Warner Brothers Studios Water Tower in Burbank, California. Weehawken Water Tower in Weehawken, New Jersey. Ypsilanti Water Tower. Standpipe. There were originally over 400 standpipe water towers in the United States, but very few remain today, including Belton Standpipe in Belton, South Carolina. Bellevue Standpipe in Boston, Massachusetts. Chicago Water Tower in Chicago, Illinois. Cochituate Standpipe in Boston, Massachusetts. Eden Park Standpipe in Cincinnati. Evansville Standpipe in Evansville, Wisconsin. Fall River Waterworks in Fall River, Massachusetts. Forbes Hill Standpipe in Quincy, Massachusetts. Louisville Water Tower in Louisville, Kentucky. North Point Water Tower in Milwaukee, Wisconsin. Reading Standpipe in Reading, Massachusetts. St. Louis, Missouri has 3 standpipe water towers which are on the National Register of Historic Places. Bissell Tower, Compton Hill Tower, Grand Avenue Water Tower. Thomas Hill Standpipe in Bangor, Maine. Ypsilanti Water Tower in Ypsilanti, Michigan. Bremen Historic Standpipe in Bremen, Indiana. Gallery